calling ambulo luku. Whatever we do, don't safu no love with whatever we do. Hallelujah to ni betoto.
Mingi Congo.
Lamin.
Na.
Lamin te jibe norin te nyame Lamin.
Kabona wulo kono.
Wulo kono nyinte mo Lamin.
Pabilenki.
Muna ngata afongole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Ngoto le Fabrama.
Namu jumara kan kuma diten.
Fabrama.
Jumara mu.
Ndele bare muso.
Lunda mana. Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramudu ma kontan.
Ngoto minaka ngala min de fon filitala. Lamin jibe nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no ko ngol ko momo.
Ngoto.
Nam.
Itedinte yalo ne Lamin hakilo diata bake karambugot. Anu santeng ministry ko di ngole si suko na amake ko do holi de
si bitun
bagona ringa
ala ni ko kede namo balo
ala ni na ko na karta bulo be damna ala ni je
ngoto
nam
ngoto mon kontan fere
jamani mu nekata
ite ka Lamin ki wulo ko no nyintay mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamol be sorande ne ko fasita wulo ko nako
karambugol ma soron ni ko karambugol soron da amake ko holiday lem ngoto dini ngo nyanta sila la ala karango la moy yamen kamen fue man kontaan andamande
alla nyin kombo courant adanda la kombo len do la jankara mol le soron do kamen courant ma rado la kombo e don do fana na kara mol soron je kara mol soron Lamin ada lo ni no la man tara fe na so kon ala mu nekela
am Lamin ite fete malon ko le sinol be ke kar radio to
nga fine
e ko nyana di mo Lamin yam na fonye
bir kabin mina kan ntambita nteri maning Fatu
ha
tambide la sugal ala dinngol bebe siri be la moyka
Fatu dan so am fana tambida jele ni subala la ngaje dinngol be jet talanta nen kili warol e be seri jelen
sa Lamin farante ku kili wo ke no la ba Lamin bita ka wulo ko no nyin taymo Lamin
amandara fenela
ite dide ko ni man si yakaru la suno la moy radio to e balon na
mu ne ka ke afonde ma nyara ni alon
telentel jikot
afonde ma mu de be ke
ite balontel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya e tarije
par ñarande kombo courant ho findira kombo ide na raje den sonka bay ko Lamin ma ñata la wulo ko kara mo be so da fa ñembe
ko to wole nati bawo ngalde ni Lamin kuntala kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu ko no bari ni ko e sisu ko no be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulan ko to batiri sanga ay si ay alamo
sa do kala
nyaadi ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandirol
ile subject ro baby jele baby jele
wala nanga coco moy fa dan so wala ngombe tambi kana ngadi ngol jebe ikadum bungo ko kala maro mo
asototal de
Lamin mala be kara wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di ko nde ko folle sinila ba ndele sinilo ne ba
mbasa mba foke en koto wole fango yen wulindi yalo famo keta bat yin fana bulata ko ko me yen nati jambi Lamin nyanta karan ntel beji ko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wara ka munda kara mo man soro Lamin nyanta kara si su na
ayala sila le ayala le sino
dal ko korno ko smalo
kilar ya
mo be ngala ko momo sa mi do ni ko no kera
mengi bruzo
ndelo ko do la da ba rosa no radio ba no bari woro radio ni abe jele ba ngamra do man dembe buljan dala nyara nyar woro ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya labi
teku
bari ko do famo ke
imagine nani nyambol si zol le keje kisigi man si zol no le kabun ka nyoma bari nyambu kino ni manya na kafindi ni nambe ko zol laga
ngale limbeta de be nyambo do dilanna
nyara ni ko ridin fennat nyara nata
bari famo ke da
ngata bungono tabi bungono nyara ngando ko ke baru nganda ni pelo la ndija
iyo awa la
bungono bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro ta koro
Hi everyone, I am Mr. Babukar Au, your chemistry tutor. And today we will start from the properties of salts. But before that, we will go back to our assessment and then we will try and answer the questions together. And then the previous questions were, one, that is number 1A, what is basicity of an acid? Basicity of acid or basicity of an acid is the number of replaceable hydrogen ion in 1 mole of an acid. 1 mole of an what? Acid. That is the number of replaceable hydrogen ion in 1 mole of an acid is termed as basicity. B, determine the basicity of the following acids. That is 1, we have CH3COOH. And this acid now is an example of an organic acid. So organic acids, their basicity is equal to what? Number of functional group contained in the compound. And then we have what? A single functional group here, which means the basicity is going to be what? 1. And the other one is H3PO4. We have 3 atoms of what? Hydrogen. Therefore, the basicity of this acid is what? 3. And then Roman figure 3, we have H2SO4. And then the basicity of this acid now is 2. That is number 1. Now number 2, tetraoxosulfate 6 acids and sodium hydroxide reacted to produce salt and water. Before going to the question itself, I'll just have tetraoxosulfate 6 acid. And then we know that acids means what? Protons. Protons, huh? So there will be no acid without what? Hydrogen. In this case, we will have what? H here. And then we know the valency of hydrogen is 1. And then this is, the question says tetraoxosulfate 6, which means sulfur is plus 6. Oxygen is always minus 2, except peroxide. If you have minus 2 times 4, we'll have what? Minus 8. So in this case, we will have what? A minus 2 charge. So we'll have 2 here. Now this minus 2 now will play the role of the valency. We will exchange and then we'll have what? H2SO4. This is going to be what? Tetraoxosulfate 6 what? Acids. Plus the sodium what? Hydroxide. So this acid is an example of what? Diabasic acid. Because they are 2 replaceable hydrogen ion. And the question reads, write a balanced equation for the formation of 1, that is Roman figure 1, normal salt. The normal salt here, or initially normal salts are formed when the cation or when a metal replaces all the hydrogen ions in an acid. So in this case, we can have Na2SO4, and finally we can have our what? Our water. You see now, this sodium has replaced all the what? Hydrogen atoms to form a what? Normal salt, which is going to be Roman figure 1. And then Roman figure 2, to form what? An acid salt. The same thing, we'll have H2SO4 plus sodium hydroxide. An acid salt must contain what? Hydrogen atom in the compound itself. So in this case, sodium will replace one of the hydrogen atoms in this solution, and then we'll have NaH. We'll have one more, and then we'll have SO4 plus water. So this is our normal salt, and this is our what? Our acid salts. And now this is everything about the assignment, that is the assessment. And now we move to the properties of salts. Now we have the properties of salts. We said salts exhibit 3 main properties. 1, some salts are efflorescent, some salts are deliquescent, and some salts are also hygroscopic. Now we will go to explain each of these properties of salts. So the first one we have is called efflorescence. Now we said this is the process by which certain salts lose their water of crystallization when exposed to air or atmosphere. For example, if you have Na2SO4 decahydrate. Now if you expose this to what? To air, it can lose all these water molecules or what? Part of the what? Water molecule. If it loses all the water molecules, we will end up having what? Na2SO4, and then we have what? 10 molecules of what? Of water. Sometimes also the same thing, we can have what? Na2SO4, we can have monohydrate, and also 9 molecules of what? Of water. But whenever a salt is exposed to the atmosphere and then it loses all or part of its water of crystallization, we say that salt is efflorescence. Now, the condition or the phenomenon in which these salts exhibit this efflorescence is called efflorescence. That is, you remove the E there and then you put there Y. That is the phenomenon or the condition or the existence in which these examples of salts exhibit. We also have deliquescence, and then we said this is the process by which certain salts absorb moisture from the atmosphere and then they form solutions. Sometimes in the lab, when you are preparing solutions, for example, you use sodium hydroxide, you weigh certain amount, maybe you weigh 3 grams of this salt, you put this or you place this salt in what? In a weighing balance. You realize that you will not be able to weigh the actual 3 grams because this salt now will be absorbing what? Moisture from the atmosphere, and then it will be dissolving in the moisture itself. And then after some times you will see what? Some water molecules attached to the what? To the salt. Which means sodium hydroxide can absorb moisture and then it will dissolve inside the what? Moisture. And this is the one of the reasons why we don't use sodium hydroxide in the preparation of standard solutions. So any salts that is exposed to moisture and then it starts to absorb the moisture, at the same time dissolve in the moisture, we said it's an example of what? Deliquescence substances. And then the process is called, or the phenomenon is called deliquescence. That is, you remove the last E and then you put there the Y. That is the condition in which sodium hydroxide and this potassium hydroxide exhibit. We also have hygroscopic substances. Now we said this is the process by which certain salts absorb moisture from the atmosphere but do not form a solution. Example, we have concentrated H2SO4, calcium oxide, cobalt-2 chloride, and also we can even have silica. Sometimes you realize that when you buy a new shoe, you will see small plastic bag and then you have what? Small weird substances there. So those substances sometimes they are made of what? Silica. They are made of silica. That silica is put inside the shoe so that it will be able to absorb what? The moisture. So they have a tendency to absorb what? Moisture. So this silica inside the shoe now will absorb all the what? Moisture without turning into what? Solution. That's why whenever you discharge it from the shoe, you find out that this what? In its solid state, but it does not what? Dissolve. So those kind of substances are called hygroscopic substances. And the phenomenon in which silica exhibit, or in which H2SO4 or calcium oxide or cobalt-2 chloride exhibit is called hygroscopy. So these substances are called hygroscopic substances. We also have hydrolysis of what? Of salts. That is salts. Some salts can be acidic in aqueous solutions, some salts can be neutral in aqueous solutions, and also some salts can be basic in aqueous solutions. Hydrolysis of salts. Now we said this is the chemical combination of a compound with water producing either excess hydrogen ions or making the solution acidic, or excess hydroxide ions making the solution basic. So if excess hydrogen ion is produced when the salt is hydrolyzed, then the solution becomes what? Acidic. When excess hydroxide or hydroxide ion are produced when the salt hydrolyzed, the solution becomes what? Basic. So when the amount of hydrogen ion or hydroxide ions are equal, we have what? A neutral what? Solutions. A neutral solution will be formed. Now we have salts of strong acids and strong bases hydrolyzed to give a neutral what? Solution. For example, we have NaCl. NaCl in aqueous solution, which means there is water. So from this salt we can have Na plus. We can also have what? Cl ions, because these are the two ions that are mobile in this aqueous solution. The two ions obtained in water also are hydrogen ions and also what? Hydroxyl what? Ions. So this cation will react with what? With this anion, and this cation will react with this anion. So here we will have sodium hydroxide, that is these two. These two also will react, we will have what? Plus HCl. This is an example of strong base versus a strong what? Acid. So the strength of the base and the strength of the acids here are equal. So when they form or when they react to form a salt, the salt becomes what? Neutral. That's why the aqueous solution of sodium chloride is what? Is neutral. So the hydroxyl ions and the hydrogen ions are what? Are equal, because this is from what? A strong acid, and this is from what? A strong base. The solution becomes what? Neutral. So you have other examples like K2SO4, that is potassium tetraoxosulfate 6. Number 2, salts of strong acids and weak bases hydrolyze to produce acidic solutions. Like if you have salts like FeCl3, in aqueous solution we will have Fe3 plus aqueous. We also have Cl minus aqueous. Aqueous, this is dissolved inside what? Water. So the water also constitutes of what? Hydrogen ions and also what? Hydroxyl what? Ions. So this will react with this and this will react with this. So when we react these two, we will have ion 3 hydroxide, and then these two we will have HCl. So this is an example of what? Weak base, and this is an example of what? Strong acid. So whenever you react strong acid with a weak base, the strength of the acid will overcome the strength of the base, therefore producing what? Excess hydrogen ions, and then the solution becomes what? Acidic, because the acid is stronger than the what? Than the base. Now number 3, we also have salts of weak acids and strong bases hydrolyzed to give what? A basic solution. Like if we have something like Na2CO3, aqueous, which means it is reacted with water. So the two ions we have in this salt are Na plus CO3 2 minus. Of course, all of them are in what? In aqueous form. In the water itself, we have what? Hydrogen ion and also hydroxyl what? Ions. So all of them aqueous. So these two will react because cation and ion. These two also will what? Will react. So we will have sodium hydroxide and also we will have H2CO3. Sodium hydroxide is an example of what? Strong base, while H2CO3 is an example of weak acid. So you see, whenever a strong base reacts with what? A weak acid now, the solution or that salt becomes what? Basic, because the strength of the base will overcome the strength of the acid, therefore producing what? Excess hydroxyl what? Excess hydroxyl ions. And then the other examples we have is K3PO4, that is potassium tetraoxophosphate 5, and also we have sodium ethanoate, which is also an example of a salt that will hydrolyze to form a basic solution. Now we have indicators. Now we said indicators, these are organic substances that changes color at a certain pH. Now indicators, we use organic substances to form or to make these indicators, and then they are sensitive to what? pH. There are certain indicators, they have certain effect when it comes to what? Acidic medium. Other indicators have certain effect on what? Basic medium, and some also have some effect on what? When the pH is what? 7, and those are termed as neutral solutions. Now the type of indicators we have is acid-base indicators and also universal indicators. Now the first one, which is acid-base indicators, said these are organic dyes that change color according to the pH of the solution. Example, we have methyl orange, phenolphthalein, etc. and etc. Now methyl orange is an indicator which is normally used when you are titrating strong acid against a weak base, because methyl orange is sensitive to what? Acidic medium. The other one is phenolphthalein. We use phenolphthalein when we are titrating strong base against weak acid, because phenolphthalein is sensitive to basic solutions. The second one is universal indicators. Now this is a brown mixture of acid-base indicators that change color over a wide range of pH. Now this universal indicator constitutes of many indicators, and it can be made up of thymol blue, bromothymol blue, methyl orange, methyl red, and also phenolphthalein. So universal indicator is the combination of many indicators, and it is not widely used when you are doing acid-base titration, because universal indicators are mostly sensitive when the solution is colorless. Now we have some indicators, that is few. They are pH and acidic medium, and the effect on acidic medium, and also the effect on basic medium. The first one we have is litmus. And now this litmus, now when you have blue litmus paper, you dip it into what? Acidic medium, it will turn to red. And then that litmus paper, that is the red one, you dip it into what? Basic medium, it will again turn to what? Blue. Which means acidic medium can turn blue litmus paper to red, while basic medium also can turn red litmus paper to blue. We also have methyl orange, and methyl orange is sensitive at a pH range around 4.4 to 6.0, and then it will form a red color in acidic medium and also a yellow color in basic mediums. We also have methyl orange, which is sensitive at a pH around 3.2 to 4.4, and it will have, or it will turn to pink when it is in acidic medium, and also it will turn to yellow when it is in basic medium. And then the last one we have there is called phenolphthalein, and this phenolphthalein is sensitive to a pH range around 8.2 to 10.0, and then it will be colorless in acidic medium or in acid solution, and also it will form a pink color in basic mediums. Now we have also drying and also dehydrating agents. Now these are substances that remove physically associated water from another substance without changing the chemical composition of that substance. For example, we have, or we produce SO2 in the lab. Maybe we use something like HCl with Na2SO3 to form NaCl plus water and also plus SO2. So this is the gas that is produced. Now when this reaction is going, so it releases heat. So that heat now will warm this water now, and when this SO2 is going off, it will go with somewhat moisture. But you don't need the SO2 with the moisture itself. You need to what? Dry it. Now, when you react this with concentrated H2SO4, see, this H2SO4 now, we remove the physical associated water contained in this SO2. So, in your product again, you will still have your what? Your SO2. And the water will what? Will go off. Maybe you can say plus what? Plus water. Because the water will go off. And this thing will be what? A dry what? A dry gas. So when you prepare a gas in the laboratory and then you find out that the gas is containing some moisture, you can use what? Drying agents to dry your gas. And when you dry the gas, the formula or the chemical composition of the gas will not be changed. You still have the same thing in the product set. Here in the reactant we have SO2, and again we will still have our what? Our SO2, which is going to be dry, and this is something like what? Wet. And the examples that can be used as drying agents are Conc H2SO4, calcium oxide, anhydrous or fused calcium chloride, sodium hydroxide, and also potassium hydroxide. Now the second one, that is B, is dehydrating agent. Now these are substances that remove elements of chemically associated water from another substance with a change in the chemical composition of that substance. And then the examples are concentrated H2SO4, aluminum oxide, which is known as alumina, and also H3PO4, which is hydrogen tetroxophosphate 5. Now here, if you have ethanol, that is C2H5OH, we normally say it is called alcohol, but the actual name is ethanol. The family name is known as the alcohol, but because it is the most famous compound in that family, I think that's the reason why people normally call it alcohol. Now if you have your ethanol and then you react the ethanol with Conc H2SO4, this can form C2H4 plus water. You see, the compound itself is C2H5OH, which is containing what? Molecules of water in it. Now, immediately we react with concentrated H2SO4. The H2SO4 will remove the water molecule it contains, and then it will turn to what? C2H4. Because we know the formula of water is H2O, which is the same as HOH. So we remove this OH from the compound, we'll have C2H5. We remove another hydrogen from this H5, we'll have what? C2H4. And then C2H4 now is called ethene. And this, the same reaction is used in the rapid preparation of ethene gas. And then you have what? Your water. You see now, this H2SO4 remove what? The chemical associated water from this compound. That's why the formula is what? Or the formula has changed. So we use here H2SO4. We also use here what? H2SO4, all in concentrated form. So this H2SO4 now can be used as both drying and also dehydrating agent. That is small note there. Concentrated H2SO4 can be used as both drying and also dehydrating agents. Now we have the assessment. And then number 1 reads, ammonium chloride was heated in a dry test tube. It was observed that the damp litmus paper placed at the tip of the test tube immediately turned blue, and after some seconds turned red. A. State the gas that was responsible for the Roman figure 1, red litmus paper turning blue. 2. Blue color of the litmus paper turning red again. So here my advice is to write a balanced chemical equation for the decomposition of ammonium chloride when it is heated. So if you know the products, you will be able to answer A, Roman figure 1, and also Roman figure 2. B. Give reasons for your answer in A above. You are required to give one reason in A1 above and also one reason in A2 above. C. Write an equation for the decomposition. That is the decomposition of the what? Ammonium chloride. Now we move to number 2. A, Roman figure 1 reads, outline a suitable procedure for the preparation of zinc chloride crystals starting from zinc granules. Roman figure 2, write a balanced chemical equation for the reaction in A above. B. Consider the following solutions. That is aqueous solution of sodium tetraoxosulfate 6, aqueous solution of potassium ethanoate, and aqueous solution of lead 2 trioxonitrate 5. Which of them has or have a pH, Roman figure 1, greater than 7, Roman figure 2 less than 7, and then Roman figure 3 equal to 7. So that is everything about the assignment.